So yeah, solving problems in 3 dimensions. They're saying that because the 3D drawing uses some perspective, right angles often don't look like right angles. So I think we are in the habit of when you see a diagram and you see that it looks like a right angle, we almost, normally we will be able to either assume that it's a right angle or they'll give us information that it is. When we're working with 3D problems, it's not always going to look like that. Okay, so they're showing you an example here. If your triangle looks like this, but they're telling you that that is a right angle, or guys, often when you are working with real world examples, right? So if they're telling you a building, for example, this line here was a building. I think we can all assume that a building is supposed to be built perpendicular to the ground, all right? That kind of thing. So usually these types of examples will be real world, almost like little word problems. You'll see in the one that we're going to do now. And then often they'll give us information. They'll tell us it's a cliff or it's a telephone pole or a building or whatever, and that will tell us that it does actually make a 90-degree angle. But guys, often it's going to look like this. And this obviously doesn't look like it's 90 degrees, right? And even that one as well. So we need to read through the information carefully, and we need to identify right angles based on that. So I would like you to please highlight that bit in bold. Mark the right angles clearly. That is very important. We're not going to do that for you. You are going to have to do that. Okay, so please highlight that bold bit there on the side. Now, if you are looking at this example here at the bottom, you can see that this triangle at the bottom, triangle PQR, we are going to work with this example now, has been shaded. That also might not be done for you. Okay, so they're going to say, or they're saying here, always shade the horizontal plane to help visualize the 3D scenario. Now, guys, the horizontal plane, if you want to make a little note there, that is the ground. Okay, so whatever is shaded, whatever they tell us is the horizontal plane, that is actually a triangle on the ground. Okay, flat on the ground. All right, so if you want to make a little arrow to horizontal plane and just write ground or floor, okay, that is always the case. So it helps if you actually shade that. Okay, I even do that myself when I'm doing these questions, just helps to kind of visualize what's going on. Then for step 3, this is what we've been doing so far anyway. All right, start in the triangle with the sufficient information to use sine, cos, or area formula and determine the shared side to the second triangle, right? We have been doing that so far. The only thing now is that obviously we are now going to be working with 3 dimensions instead of in 2. Okay, so let's do this example. I've tried to draw it on here. Again, just bear with me. So if you haven't copied it down yet, there it is. Okay, you can finish copying it down. You can see there that I have shaded what they are telling me is the horizontal plane. They will have to do that in the question. Okay, if they're not shading anything, then they will tell you. So there they're saying P, Q, and R are in the same horizontal plane. So I'm just going to highlight that bit as well. That is what we are shading. Okay, whatever is the horizontal plane, that is what we say. You can just finish copying that down quickly, and then we'll work through it together. Now, guys, the visualization here is quite important. All right, let's just read through what they're saying there. They're saying in the figure alongside, B is a balloon. All right, so that point there at the top, B, that is a balloon held in position by 3 wire stays. I suppose it's just like a piece of wire. PB, BR, and BQ. So that B is a balloon in the air and it's held in position by 3 pieces of wire that are tethered to the ground. Does that make sense? And we visualize that. So B is the balloon in the air. All right. This shaded plot is on the floor, on the ground. All right. Imagine a triangle that has been drawn connecting the bottom ends of the 3 wires. Okay, I'm going to say that again. B is the balloon. It is held in place, right? So that it doesn't move by 3 pieces of wire that are attached to the ground. All right. And at each point where those 3 wires are attached to the ground, between those points, they've drawn a triangle. And that is the triangle that we've shaded. Okay, so what we actually need to understand is that we actually have 4 triangles here in this scenario. We have the triangle on the horizontal plane, on the ground, on the floor, okay? PQR. Then we have triangle BPQ, which is almost like at the back. Okay, remember B is like in the middle. All right, the balloon. So we have triangle BPQ, which is at the back. Then we have triangle BQR, which is like on the side, like a slanted triangle, and triangle BPR, which is on the other side, also a slanted triangle. So guys, I can't, for example, calculate this angle here. If we had that angle there, for example, you couldn't say, oh, that's a triangle there on the ground. I'm going to use angle from a triangle. Okay, this is not the traditional kind of diagram where it's flat. Okay, I hope that makes sense. It might take some time to get used to it, but you do really have to take some time when you're reading through the actual instructions, the question, you need to identify what's actually going on. Okay, then they're saying all these values that they've given us, I think they are all filled in on the diagram, but let's just check. BP is equal to BQ. And guys, if we see that, what do we know immediately? If BP is equal to BQ, it's obviously an isosceles triangle. So that 35-degree angle is also going to have to be equal to that angle there. All right, so let's fill that in. That angle there is also 35 degrees. If we want to use that, we need to actually write it down with its reason. Angles opposite equal sides. But we can pull that in so long. Okay, that's information that we can get. And guys, if we have that 35 and that 35, that together is 70, right? Then if we're thinking of that back triangle now, triangle BPQ. If those 2 angles are 70, what's that top angle going to be? 110. Okay, so we can pull that in as well. We might not need to use it, but we might have to. Okay, just remember that is now an angle in the back triangle. Okay, this line, BR, is not cutting into that angle. Okay, BR is not now a line that divides that angle into 2 parts. Okay, we need to keep thinking of that. Now, it will get easier as you practice more of these. Okay, it was a bit confusing in the beginning, but I'm sure you will be fine. Okay, next up they're saying QPR is 68. We have that. PQR is 42 degrees. BPQ is 35. Okay, we've already used that. And then PR, that line is equal to Q. Okay, so everything is filled in on the diagram. We can also calculate this angle here at the bottom. What is that? Is it 70? Thank you. All right, so angle PRQ there at the bottom is 70 degrees. And that is now in the horizontal triangle. Okay, the triangle that's actually on the ground. Okay, first question. Not really an easy one, right? Normally the first question is like calculate this angle. But anyway, we can do it. Show that PB, so that line there, okay, is equal to Q sine 35 over sine 42. Now guys, the fact that they're saying sine 35 and sine 42, that's already making me think that I need to use sine rule. Okay, do we agree with that? Right, we have sine and sine, so we're obviously going to have to use sine rule. So guys, step 3 of the 3 points that you wrote down, we're saying work in the triangle with the most information, find the shared side, and then work into the other triangle. Okay, now the shared side obviously is PQ, so you can highlight that if you want. There we go. PQ is the shared side, so we need to find PQ. Now, which triangle has more information? The one on the horizontal plane or the one there at the top? What do you guys think? So the one at the top has 3 angles, but we have no sides. Right? Do we see that? Remember, if we want to use sine rule, we do at least need one side. Okay. So I'm actually going to start working in the bottom triangle because we have a Q there. Okay. The shared side is PQ. So we can say PQ over sine 70 is equal to Q over sine 42. Okay, so we agree with that? Okay, I'm going to say that again. If we're working in this bottom triangle, the green one, and we're working with sine rule, I'm going to say PQ over sine 70 is equal to Q over sine 42. But guys, remember this 70-degree angle wasn't given. We calculated it, so we first have to write that down. Okay. So first we're going to say, what is this? Triangle P or angle PRQ. (70 degrees) angle sum in triangle. Yeah, now we can use sine rule in that bottom triangle there. So now I'm going to say PQ over sine 70 is equal to, so PQ over sine 70 is equal to Q over sine of the opposite angle. So Q over sine 42. And guys, we can already see that we have some of what we're trying to prove. Right? What are we trying to prove? We want to have a Q at the top and then a sine 42 at the bottom. We already have that here. All right. Now to get PQ on its own, remember the shared side, we need to multiply the other side by sine 70. So I'm going to put it at the top. Are we fine with that? I'm going to have Q sine 70. Okay, so I'm going to say PQ is equal to Q sine 70 over sine 42. And guys, I want to urge you to do that, okay? Even if you don't know where to go after that, if you at least are finding the shared side, 99% of the time, that is what you need to do, and that will get you marks. Okay. All right, so we have an expression for PQ. Now we need to use that expression. Remember, what are we trying to find? PB. Okay, so that side over there. That is the one that we are trying to show that it's equal to this whole thing. So let's see, again, they're using a sine 35 and what I'm supposed to prove. So let's see if we can actually use sine rule now in this triangle, and we can, right? We can say PB over sine 35. But remember, before I can use that 35, I need to say that it's 35. Okay, angles opposite equal sides. So we'll write that down now. So PB over sine 35 is equal to this expression, right? PQ over sine 110. Okay, which we also calculated, so we need to work that out. Okay, and that will then get us to the answer. So let's quickly just write down those angles. PQB is 35 and PBQ is 110. We need to just write that down. So the 35-degree angle was because it's an isosceles triangle, but remember we need to say angles opposite equal sides. And then the other angle, PBQ, was 110. And that was angle sum and triangle. Okay, so now I'm just going to go back up to the diagram so we can see it. Now we're going to just use sine rule again. So PB over sine 35 is PQ over sine 110. I'm going to leave actually subbing in this whole expression for PQ until a bit later. Okay, we don't do that right at the start, so then we end up with quite a complicated thing to work with. So now I'm going to make PB the subject. I'm going to move that sine 35 over to the other side. So we're going to have PQ sine 35 over sine 110. Now guys, you can write this next step down as a separate step, okay? Maybe just for this example, you can do that. I'm sure we did it last year as well, but let's just recap. This PQ, I can make separate from the whole fraction, right? So I can actually write PQ in front and then say that I'm multiplying it by the rest of that fraction. Okay, and I can't do that because it's all one term here at the top. All right, then we've got the PQ plus sine 35, then you can't take the PQ off. Okay, but if it's PQ times sine 35, you can actually take the PQ out and write it in front. And that will just make the actual substitution now of this whole expression much easier. Okay, because now, instead of having that whole expression as a fraction in my numerator, I can just write this expression in front. Okay, so see what I'm going to do? I'm going to say that PQ is Q sine 70 over sine 42. Right, that was PQ that we found up there. Times sine 35 over sine 110. Then you can obviously put that all together as one fraction, right? When you're multiplying two fractions, you just multiply the numerators and the denominators. But then, do we agree that there's more stuff there than what they asked us to prove? Right? If you look at what they asked us to prove, it was just the Q sine 35, so the Q and the sine 35, and at the bottom just the sine 42. So I need to get rid of the sine 70 and the sine 110. How can I do that? Yes. Yes, good. 110 is the same as 180 minus 70. Right? Do you agree with that? So guys, I'm just going to circle these two things because this is now what you need to ask yourself, right? There's now, or you are now left with something there that you are not supposed to have in your final answer. The sine 70 and the sine 110. So you need to work on those two to somehow cancel them out. All right, so here I'm going to keep my Q sine 70, and now I am actually going to write it all as one fraction. You don't have to if you don't want to. You can still leave it as two separate fractions. That is the numerator. And in my denominator, I now have sine 42 degrees and sine 180 minus 70. All right, so we're using a reduction formula there to change sine 110 to 180 minus 70, and we know that 180 minus is which quadrant? Quadrant 2, right? So quadrant 2, this one here, what is sine in the second quadrant? Positive. So this is just going to become sine 70. Unfortunately, you will have to show that. Okay, so it's quite a lot of writing, but they do want to see in matric finals, they want to see all of those steps. They actually give marks for all of those separate steps. So again, we have Q sine 70, sine 35. Over sine 42, sine 70, and now you can cancel those out. Right, the sine 70 and the sine 70, you can cancel them out. So then finally you are left with what they asked you to prove, Q sine 35 over sine 42. Now guys, in terms of the actual triangle rules, right, sine cos area rule, I don't think this was too bad. Yeah, it was similar to what you've been practicing already. I'll just go back up to the top quickly. I'll move down again just now in case you're not done there. But what we did was we used our knowledge of triangles to calculate some angles, right? The 35, the 110, the 70, we all could have done that. And guys, because we actually had to use all three of those values, you would have gotten marks for all of that working. Okay, so even if you did a blank and you didn't know which triangle to start in or whatever, you forget how to use sine rule, you will still get marks for actually calculating those angles. Okay, so we usually say at the beginning of the question like this, just find as many angles as possible, and you will probably get some marks for that. Okay. Then next up, we used sine rule in the bottom triangle, which you all can do, all right? And then we used sine rule in the top triangle, which you can also all do. The only extra thing here was that we had to change the sine 110 to sine 70. But again, I think that's something that all of you can do. All right, we just need to be on the lookout for that. Okay, so that was question A. Any questions on that one? All right, for B, let me just see what is the question in B. Okay, we'll just check. How am I doing for space here? All right, we'll be on the side here. Okay, now for B, they want us to calculate Q if PB is equal to 54.5 meters. Now guys, in these types of questions, we know that usually B relies on A. Okay, now again, I just want to reiterate that in A, they said, show that PB is equal to this. Now, even if you weren't able to show this in A, you can still use that in B. All right, that's why they didn't just say, find an expression for PB. They could have done that, all right, find an expression for PB. They might do that, then you still need to be able to do all of this. But they actually told you in the question what PB is equal to. Meaning that if you're not able to do A, you can still use this in finding your answer to B. Now guys, they told us what PB is now. Hey, PB is 54.5. They're asking us to calculate Q. All right, so I'm just going to rewrite this on the side. So they say, we've just proven that PB is equal to Q sine, what is it, 35 over sine 42. Oh, sorry. And now they've given us the actual value of PB. All right, so now we're going to put that value into PB and we're going to solve for Q. Okay, can we all do that on our own, please? I'm just going to put the Q part on the left. You guys know that I like what I'm solving for to be on the left. So I have Q sine 35 over sine 42 equal to 54.5. And now I need to solve for Q. Right, it's just calculator work, right? It's a normal equation that you are solving, so do that with me. You can do it in multiple steps if you want. Right, so guys, you actually could have done that all in one step, so don't stress if you didn't write all of that down. I'm just showing my steps. So you would multiply that side by sine 42, and then you left with that, and then you would divide by sine 35. You can also obviously like work with decimals in your calculator. Just a reminder, guys, that if you're working this out, right, 54.5 sine 42, you're not allowed to round that off. Okay, you just need to work with the answer in your calculator, and then divide that by sine 35. Did we get that answer? 63.5. Okay. So guys, just again, even if you weren't able to do A, you can still get full marks for this question. All right, by using what they said you must prove in A. Please remember that. I see a lot of people when I mark finals, they can't do the first question, they just think, oh, I won't be able to do anything else, I'm just going to leave the whole thing off. All right, but often you can actually do some of them. Okay, I'm going to give you some of these to practice on your own. Let me just check what they're saying here in the note. You just had to do number one from that worksheet, hey? Heights and distances worksheet, you just did the circle one, and then there was one question from the textbook, is that correct? Okay, so on that worksheet, I would like you now to do numbers 2 and 3. I'll put them on the board for you. These are just, so number 2 is a 2-dimensional question, and then number 3 is a 3D one. All right, so this is the same worksheet that I posted on Classroom for you yesterday, so you can go find it there. You were supposed to do this one for today. Now for tomorrow, I would like you to do number 2 and then number 3 as well. And guys, note that number 2 is 2-dimensional. Okay, number 3 is 3-dimensional. They have shaded the horizontal plane for you. I just quickly want to read through number 3 with you. They're saying AC represents a vertical tower. Guys, if they say that vertical tower, it has to be perpendicular to the ground. In this exercise, they did indicate that, but guys, often they don't. Okay, so there you can see, like I said, this doesn't look like a 90-degree angle. If you look at the triangle, right, it looks like an obtuse angle actually, but you need to understand that it's a triangle that is drawn kind of slanted. Okay, so that is 90 degrees, meaning guys that that is also going to be 90 degrees. So when you are drawing this triangle, this diagram, you can fill in a 90-degree angle over there. Right, I usually draw it a little bit bigger than the other one. Okay, so it's kind of like that. And it doesn't matter. Right, so that is a 90-degree angle, that will also be a 90-degree angle. So this is a tower. Okay, it's perpendicular on both sides of the tower. Okay. Then they're giving you some more information there. You can read through all of that. Show that BD is 1 unit. Okay, that's the first question, which is a bit strange, but obviously you'll have to be able to cancel some stuff out. Okay, so please work on that now, guys. Number 2 and number 3. And I'm here to help if you need.